Okay. So, let me recap back. The last session we learned to calculate the resultant force for the plane area at different angle. The first is 90 degree, which is vertical direction. Secondly is having an angle. Alright. So we learn to calculate the resultant force as well as the directions where the resultant force acting on the plane. Alright. So what is the coordinate? How to find the coordinate of center of pressure? Do you still remember the equation? What is the equation? What's the formula? Alright, so for example, we have the plane. Alright, this is the plane having an angle. So where we should have an angle? So this is the angle. So this is water. Alright, this is angle. Okay, alpha. So where is the resultant force? The resultant force acting here. Alright, so based on the resultant force, should be perpendicular to the plane. So what it means by perpendicular? You can see the angle. So from here, you can label the resultant force, which is Fr. Fr is the resultant force. So what is the formula to calculate the resultant force? So Fr is equal to, anyone? Fr equal to, pardon?
Pythagoras theorem, the hypotenuse.
Okay. Basically,
Normal
Fr is equal
Gamma.
to
F.
gamma
Sine theta.
Times
H
Times-
HC.
times
Remember? Time A. Alright.
Times
So,
area.
yes, or gamma Y. Okay, YC sine theta or sine alpha time area. So basically, this is the formula that we frequently use through the fluid mechanic, all right? Because we need this formula to solve the resultant force. You learn how to calculate the resultant force. This is magnitude. Remember the force consider of vector or scalar?
Vector.
Vector. So vector should have magnitude and
Direction.
direction. Mean the position. So this is what we learned previously to find the coordinate of Fr. So the equations to calculate the coordinate, this is the equation, all right? Y CP, this is centroid to the pressure point CP is equal to negative. Remember, negative means it is below the centroid position. YCP equal to I XX, second moment of area, multiply with sine, all right? Sine theta over with HC time area. Okay. For example, where is the centroid for this plane? Where is the centroid for this plane? Okay, Amma, do you have any question?
Above A4.
yes, doctor.
Okay.
For the shapes of second moment of plane, are these the only shape that we have to know, or there will be other shapes?
There will be, yes, that is good question. you must know other shape as well. Can you see this is rectangular?
Yes.
This is triangle.
Yes.
This is the circular, semi-circular. You need to know all of this. All right. So basically, the concept is the same. Don't worry. Once you understand the rectangular shape, if you solve for this, that will be easy for you. That is why you need to understand the concept first. Okay, Amar.
Okay. Thank you, Doctor.
All right. The reason why I use the rectangular element or the shape because it is common used in many fluid mechanic problem. All right. Sometimes if the question give you the different shape, you just use this formula. That's it. Very simple. The change the different is the formula IXX. All the same. Okay. So IXX refer to the different shape. For example, if you, okay, for example, all right, can you see IXX refer to this one? All right, it is, sorry. All right, IXX refer to the different shape. For example, rectangular, IXX is BH cube over 12. For the triangle, the IXX is BH cube over 36. For the circular area, IXX is equal to pi r the power of 4 over 4. Alright? It is very simple. Just different in terms of IXX. The rest is the same. Alright? So IXX sine theta over HC. So for example, if you find the YCP, so where is the YCP? So first you need to know the centroid. Where is the centroid, everyone? The centroid of the plate.
Center.
At the
At
center.
the center or at the middle, right? We label here. So the YCP is actually the distance from the centroid to this one. This is what we call YCP. Everyone understand? So far clear?
Yes, Doctor.
Okay. You must know, can you see this is negative? All right. The negative means it is below the centroid. That is why it is negative. When it is positive, it is above the centroid. Okay, so far you guys clear about this?
Yes, sir.
Okay, I hope you understand. Okay, so now let's try to look at one example. All right, this example we have a door. All right, a door is 1.2 meter long and 0.8 meter into the pitch. So it is the width into the pitch. Find the force F. Where is the force? This is the force. All right, on the gate and its center of pressure position. That means the question requests you to find the YCP. Neglect the atmospheric pressure. So when the question tell you neglect the atmospheric pressure, so that means your PATM equal to
Zero.
Zero.
yes, your PATM definitely equal to 0. So you don't consider at all PATM. So your case now it is the gauge pressure, right? So first, find the force. So how to get the force? Find, all right, step first, find the force. So how to calculate the force of the plane? What's the formula? F resultant force, alright,
equals to
okay, the F equal to
rho.
rho or gamma also can be
Gamma.
considered.
No, gamma.
Okay, gamma of what? Can you see this one?
Oil.
Gamma of oil, alright, multiply with
HC
AC multiply
Area.
with
area.
area. Okay, perfect. So, gamma, how to get the gamma of oil? With the
Times
given-
1000.
Okay, times 1000 is actually density. Don't confuse that. If you want to get density of oil, Sg multiply with density of water, which is density of water is 1000, right? So, if you want to find the gamma of oil, Sg multiply with gamma of water. So, what is the gamma of water?
1000.
1000 is density of water. So, formula of
1000 times 9.81.
yes, gamma of water is equal to rho multiplied with gravity. So, rho of water is 1000 multiplied with 9.81. So, in order to calculate the gamma of oil, specific gravity of oil, which is 0.82 multiplied with gamma of water, which is, what's the value here?
9810.
Yes, 9810. Alright, please don't confuse with the density. If the question give you find the density, multiply with density of water. If you need the gamma of oil, multiply with gamma of water. Okay? Okay. So gamma of oil 0. Can you solve this? Okay. 0.82 multiply with 9810 multiply with HC. How to get the HC? Where? Okay. First, you need to consider where is the plane. The plane is the door, right? The door is the plane. Where is the door centroid? The centroid of the door?
0.6.
0.6 at the middle, right? This is the centroid. So 0.6 plus 1 is the slanting one. I want the H. How to get the H? Okay, this is...
Pythagorean theorem.
Okay, good. So this is 1 plus 0.6. So this is 1.2.
1.2.
1.2? Are you sure?
2.2. 1.6. Allah Akbar.
1.6. Okay, 1.2.
1.6.
1.2, 1.6. Okay, 1.6. Alright, meter. So I want to get this height because this refer to height. This is lengthening. Okay, we have angle here, 40. So how to get this height?
1.6 sine 40.
1.6 sine.
40.
Yes, good. So this is height. Is it H refer to HC?
No.
Okay, this is H. Remember your H. How to get the HC? You have to plus what? What you need to plus to get HC?
Plus 4, Doctor.
Yes, you need to plus 4. Can you see this 4? This is the rest of the height. This is h. So that means you get this value h, you need to plus 4 because it is the reference level here. Can you see? It is at the surface of the water. So HC is equal to 4 plus 1.6 sine 40. Anyone, do you understand so far?
Yes, Doctor.
Okay, so what's the value? Can you help me to calculate?
5.02.
Pardon? 5 point,
02.
point,
Oh.
point.
02.
3.
Okay, is it okay?
5.19.
Or 3?
No,
Yeah.
it's 5.03.
Okay, 3. Alright, 0.03 meter. Alright, so just plug in the value 5.03 multiply with area. What is the area? Area of what? Area of the door. So what's the area of the door given?
1.20, 0.8.
Yes. So 1.2 multiply with 0.8. So what's the value, everyone? It is?
38843.
Yes. 3, 8, 3, 8,
843.
4, 3.
Yes, 0.8.
Hmm?
It's correct.
Okay, 3, 8, 8, 4, 8.
Yes, doctor, it's correct.
Okay,
It's
this is
correct.
correct, yeah? Okay.
Yes.
Okay, this is Newton. Alright, so now you have found the resultant force. So how to get the coordinates or the centers of pressure? So can you see this is x? So based on our equation, which is y, okay, let's use this one. Secondly, find y CP. So what's the formula of YCP? Negative I XX sine theta over HC time area. Okay. So the most difficult part is actually IXX. Alright. So IXX. What's the IXX? The second moment of area. So once you refer this, okay, can you see our area shape is rectangular, right? So can you see we have IX and IY? Which one should we choose? X or Y?
X.
Okay, we should
X.
choose X.
X.
Betul, saya nak tanyakan yang apa tu yang second moment of plane ni apa kaitan dia dalam pressure ni?
Because we need to find the location of resultant force.
Oh,
Because force consider vector, right? Should have magnitude and direction. So you must find the location which the resultant force act. Is it from the centroid or away from the centroid?
oh.
So you need to find the location. So that is why you need the IXX.
Okay.
Okay. So can you see here? Alright, this is YCP. Okay. This is very important. I want you to focus on this. This is critical part. Okay, this is our plane, right? Okay, let's draw our plane here. In here. Okay. This is our plane. Okay, so when we draw our plane, we must specify the coordinates. Which one is X or which one is Y direction. Okay, so please remember that this is the plane. The Y axis always parallel to the plane. Remember this. Okay, I highlight the red color. This is Y axis. And where is the X axis? Should be perpendicular. Is it this way or the other way?
Both downward.
Okay, if you confused, you can use
Upward.
your right hand rule. Can you see my right hand rule? Okay, this is start from X going to Y. X going to Y. So where's your thumbs? Upward or downwards?
Upward.
Upward. So where is the correct X?
To the right.
Okay, to the right. Okay, so everyone understand so far? Okay, so this is your Y and this is X. So from here, when you refer to this table, can you see IXX refer to? Okay, IXX refer to BH cube over 12. So B, is the B parallel to the X axis? Okay, this is your X. Okay, and this is Y. So so now you focus your Y axis because your Y parallel to the plane, right? So this is your Y. What's the value parallel to Y? Is it H or B?
H.
So H. So can you see H the power of 3? Okay, everyone? The H is bigger, the power of 3. Don't confuse. Don't put B as your H. So look at here. When you use IXX, alright, please choose H that is parallel to the Y to be the power of 3. Okay? So for this case, so let's list the formula. So what's the formula? I X is equal to B H over 12. Alright? So where is the H? Is it this is H or this the depth of H? What is the H?
Parallel to Y.
Yes, please remember the H should be parallel to the Y. This is H. So the other way, the B is the width. Alright? So from here, just substitute the equation given. So IXX equal to, so what's the B? What's the value of B here?
0.8.
0.8.
8.
So what's the value of H?
1.2.
Yes.
1.2.
1.2 the power of
3.
3 over
12.
12. So what's the value?
Zero 0.1152.
0.1152. What's the unit?
Meter 4.
Yes. Meter the power of 4. Okay, so It's easy for us now. Just substitute this equation. So YCP is equal to negative 0.1152 sine 40 over with HC. HC we discovered previously is 5.03. And the area, what's the area? 1.2
0.96.
0.8. Okay, so what's the value here? Can anyone calculate for me? What's the value of YCP? Is it negative value? I believe it is negative, yeah?
Negative 0.
015. 153.
153 meter. All right, so what do you understand of this value, negative 0.0153? It is below what?
It is below the center of
Center.
It is below the centroid. All right, where's the centroid? This is centroid, right? So below here, this is centroid, okay? So below here is YCP. So how to calculate the X? So from here, we know that the X is actually, what's the value of X, everyone?
1.2.
Okay.
No.
No. Okay, how to get the value of X? We know already YCP.
Okay, centroid dia kat situ.
Okay, this is centroid.
Ah,
Centroid itu berapa? What's the value of centroid?
dia 0.6.
0.6.
Okay, lepas tu dia punya YCP dia ke bawah.
Okay, this is 0.6. So YCP dia, so the value of YCP is
Bawah centroid
0.0153.
153.
So what's the value of X?
0.6 plus 0.0153.
Yes, correct. 0.6 plus 0.0153. So what's the final value?
6153.
0.6153 meter.
Buang
Okay, everyone.
aloh.
Okay, you guys understand so far how to calculate the
Alhamdulillah,
centroid?
Doctor. Understand it.
Doctor, can you please repeat how to find X?
Okay, it's better. Shafiq, can you explain?
Yes, Doctor. Which
Okay.
one you want me to explain? Can you repeat the question?
Can you please explain how to find X?
How to find the X?
Yes.
Okay.
Okay. So do you know how we get the YCP?
Yes, I know how to.
Okay. So now you know you already know the value of YCP, right?
Yes.
Okay. So first of all, what do you know about YCP is a value or a distance below the centroid, right?
Yes.
Okay. Now where is the centroid?
At the middle of X.
Yeah, in the middle of X, right?
Yes.
So now, if centroid is in the middle of X, now where is the YCP?
In the middle, right?
Okay. In the middle is centroid, right?
Yeah.
So YCP is below the centroid.
Below, yes, exactly.
Yeah.
Below.
So it will be below a little bit, right?
Yes.
Okay. So now, where is the F?
Where is the what?
Where is the where is the F located?
Below the X.
Yeah.
Below,
Is it
yeah.
on the YCP, right? Can you see the?
Yeah.
Okay. So to get the center of pressure position X, you have to sum up the 0.6 plus with a 0.0153 here. So you will get this distance. You know what I mean?
Yes.
Are you sure?
Yeah.
Are you sure? Okay.
Yes.
Ah.
Understood.
Okay, I understand. Yeah, this is the centroid 0.6. It
2
is
marks. 2 marks.
it is at the center. You just plus the YCP. It is just below the centroid. So now you know the value of X, where the location of force. Okay?
Okay, doctor. Thank you.
Okay. Thank you, Shafiq, for the good explanation.
Welcome.
Anyone? Well, do you have any question? Okay, I hope you understand, yeah? I explain to you step by step tau, actually. So I really hope you understand clearly
Hello?
for this.
Hello, yes. Sorry?
Shafiq,
Okay.
can you mute?
Okay. Okay. Let's try for the last example, everyone. So before we start, I would like to have a 5-minute break, okay? Before we continue. Okay, everyone. Okay, I think we shall continue. Okay, are you guys there?
Yes, doctor.
Yes, doctor.
Okay, I hope that for this part, this is the last example, and after this, I'm gonna record myself for the tutorial and post it through the e-learning. All right. So this is very important. The second understanding. I believe the first part you might be confused, blur. For this case, I want you concentrate. Okay, this will enhance your understanding. Okay, the same thing happened. Okay, so for this case, all right, let's understand the question. Gate. Previously we used door. Now we have gate. Gate AB. This is A to B. Has length L. The total length L. Width B, which is into the pitch, is hinged at B. So when it is hinged at B, we already know we have the reaction force at B. Remember, when something have the hinge at the particular point, we have the reaction force. Okay. So, and has a negligible weight. So that means this gate has the negligible weight. We don't consider the weight at all. The liquid level H, alright, the liquid level H stay at the top of the gate for any angle theta. Okay, this is theta lah, referred to here. Find the expression for the force P perpendicular to AB. So the question asks, find the pressure force. The force P perpendicular to the AB that keep the gate in equilibrium. Alright, so we know that once we dip the gate, we have the force acting on the gate. So in order to counter it back, in order to make sure the gate in the equilibrium state, we need to pull the gate with the pressure force. This is the P. Okay, so far you guys understand what the question asks? What's the value of P in order to keep the gate equilibrium? Static, not move. So, do we have any other forces other than P, everyone?
Yes.
Okay, what's the
Alright.
forces involved?
So
To
the weight of the gate is there.
maybe I
Sorry, negligible weight, but due to
The reaction
the
force at B.
liquids, due to the
Okay.
liquid.
Force at 3.
at P, at
Pardon?
point P.
Okay, at point P, the center of pressure. So let's say this is the center of pressure here. Okay, this is at point P. So we have the resultant force due to what?
Due to pressure.
Pressure.
Yes, hydrostatic pressure. So the first step, we need to calculate the resultant force. So what's the formula of resultant force? Fr is equal to gamma of what? For this case, it is not
Gamma
given.
H
Gamma H
HC area.
time area. I think this is very simple, right? This topic. Okay, so because it is very short formula. Okay, so gamma. Wait, yeah. So for this case, where is the HC, everyone?
HC.
From the reference to the center of the gate.
Yes, center of the gate. So this is centroid. First, you need to label the centroid. So what's the value of HC? So what's the centroid here? What's the distance from the centroid? L
by 2.
Divided by 2.
L divided by
2.
2. So when this is L divided by 2, definitely this H from here is H divided by 2. Can you see this is total height? Alright. For this case, the centroid, this is H divided by 2. So far, you guys clear?
Yes, doctor.
Yes, doctor.
Okay, so this is H. Okay, this is H divided by 2. Alright, so just substitute the equation. Alright, gamma and H, this is H over 2. I think H over 2 multiply with area. What's the area of this plane?
L into B.
L multiply with B, which is L B. Okay. So try to simplify. H L B gamma over 2. So now you find the resultant force. It is pretty easy, right? To get the resultant force. Okay. So next, what we need to find, everyone? This is the first step. Second step, of course, we need to find
IXX.
okay, before IXX, we need to find Y
So YCP.
YC.
YCP. Why we need to find YCP?
To know
Because
the distance of FR.
Because of Later on, you going to use the length of YCP to find the moment at point B. Remember, we're going to use the moment. The summation of moment equal to 0 at point B, so that we can find the value of P. Everyone clear?
Ya, Doktor.
Okay. So, we need to find YCP. So, what's the formula? Negative I XX sine theta over HC time area. So, what's the formula of IXX? So, this is rectangular IXX is equal to B H cube over 12. So, how to locate the coordinate? Where is the y-axis? Where is the x-axis? Remember, the y-axis always
Parallel.
parallel. Okay, the y-axis, okay, always parallel to the to the plane. Okay, so for this case, okay, this is y-axis. All right. So what's the value of h, everyone? H refer to
L over 2.
L over 2. Are we have the moment half of the plane, or we have the complete of the plane?
L.
So
Yes. The H is actually the total of the plane. We are not focused on the half. It is the complete of the plane. So it is L basically. So the value of here, just substitute here. Negative IXX is the B. What is the B? B is width, right? This
B.
is our B. So B time L cubic, all right, over
12.
12. Sine theta, all right, we have theta here. Okay, over with HC. What's the value of HC? Which is H over 2. Multiply with area. What is the area? L multiply with.
B.
Okay, can you simplify further? Can you simplify? You can simplify B. 2, 12, which is 6. L with L, the power of 2. Alright, so what do you left here? Right, so you will get here is actually negative L squared over 6 sine theta over H. Okay, so from here, you need to apply moment. Okay, because why you need to apply moment? Because you need to find the equilibrium force. Can you see it here? The equilibrium. Okay, so you need to find the summation of force. Okay, the third step here is you need to find the moment at point B. Why we choose at point B? This is the tricky question. Why we choose at point B? Okay, this is our direction of movement. Anti-clockwise is positive. Can you see when I try to rotate my right hand rule, our thumbs pointing upwards. So, pointing upwards is positive. Summation of movement at point B equal to 0. Anyone have taken static? subject?
Yes,
Static.
doctor.
Yes.
Yes,
So
yes.
if you have taken static, I believe you understand. We choose at point B because of what?
Sebab ada reaction force, kita boleh ignore.
Yes, pandai pun. Perfect. If we choose at point B, we have the reaction force. Remember? Reaction force B and reaction force. This is vertical and this is horizontal. If we choose the moment at point B, we can omit the reaction force. Is it clear?
Clear.
Yes, yes.
Alright. So, so let's start with the pressure at P. So P pointing, is it clockwise or anti-clockwise? We try to move
Anti-clockwise.
anti-clockwise. So your thumbs pointing upwards or downwards?
Upwards.
Upward. So upward is positive. So P multiply with, this is the length.
L.
Okay, it is positive. Another force is Fr. Fr is positive or negative?
Negative.
Negative.
Because
Negative.
can you see? It is clockwise, your thumbs, okay, into the page. It is negative. Negative Fr. What is the distance here?
YSB.
L minus L over 2
Negative.
plus YCP.
When we talk about moment, we are not consider negative or positive, just the distance. Okay, what is the value of here?
L
Okay.
minus L over
YSB.
Okay,
L over 4.
the centroid. Okay, B to the centroid is
L over 2.
L over 2.
Minus
From the centroid to the F is Y CP. How to get this value?
L over 2 minus
L over
YCP.
2 minus YCP.
Yes, correct. So this angle, this length, for example, this is X, yeah? This X is equal to L over 2 minus with YCP. So far, you guys understand?
Yes, doctor.
Alright. So just substitute L over 2, which is half of this length, minus the one that we don't require, which is minus YCP, equal to 0. So in order to get the P, just move P equal to FR L over 2 minus YCP over with L. Okay, clear so far?
Yeah, doctor.
Okay, so just substitute the value. Alright, I try to make it here, yeah. Okay, so P equal to FR. Okay. So what's the, sorry. So what's the value of FR that we have discovered previously? This one, right? Everyone?
Doctor.
Yes. Just substitute there. Just substitute H L B gamma over 2. Alright? Bracket L over 2 minus YCP. YCP is negative. Negative with negative is positive. L squared over 6 sine theta. Okay. This is H. Alright. Over with L. Okay. Can you simplify further, everyone?
Yes.
Okay, so we can simplify further. Alright. So from here, you can simplify L with L. Okay. So you can say that P equal to H B gamma over 2. Okay, you can put this way also can be accepted. L cube. Okay, can you see this is H? This is H, right? Okay, we can simplify further. Cannot. Because this is not in terms of H. It's okay. L squared over 6 sine theta over H.
Doctor, we can multiply it with the L over 2
Yeah.
and then simplify it.
Yes, you can do as well. But it's going to take me a long calculation lah. But I want to show you only this method. You can further simplify. Everyone, okay? You can multiply. It's okay. Okay, everyone.
Ya, doktor, okey.
Okay, so far, faham tak? You guys understand tak the concepts? How to get?
faham doctor.
Okay.
Yes.
Okay, nice. Even it is only 1 hour, but you managed to grasp, to understand the concept of the resultant force on the vertical plane having a different angle, right? Okay. So the next part, I'm going to record myself for the tutorial and post it to the e-learning. It is quite the same here. Alright, once you look at my step-by-step tutorial, you will definitely understand. Okay, so far, everyone okay?
Okey, doktor.
Okay. Kita pergi sikit lah, we go a little bit lah, alright?
Okey, doktor.
We try to cover the concept, very simple one. Okay, and then we stop. Okay. Okay, I hope that for this part is quite short. Okay, so next we cover of the forces on the curved surface. Previously we covered the vertical plane area, right? So now we have the curved surfaces. Alright, so for simplicity, let me draw the curve. So what do you understand for this curve? Okay, we have the curve. Alright, so this is our plane. Alright, in order to calculate the resultant force, okay, this is the plane. Alright, in order to calculate the resultant force acting on the curvature surfaces, we need to establish two things first. First, we need to establish the projection of the horizontal and vertical axis. Okay, so what I mean is that, where is the projection of the horizontal? Where is the horizontal position? This is horizontal, right, everyone?
Yes, doktor.
Okay, so we try to project. This is the projection. Okay. Okay, this is the projection of the horizontal and the projection of vertical. Okay, now let's take this out, all right? So now we have the vertical. Okay, and then we have the projection. Okay, let's say for this case, I think not the same. Okay. All right, let's take this as a projection. Okay. Okay, so now what force that we have here? Anyone knows what the force that we have here? We have the anyone? Do we have
The
we have the horizontal force?
vertical ke horizontal?
Okay, this is vertical force, alright? Okay, and then we have the vertical force. So
Horizontal.
this is horizontal. This is vertical. Can you see?
Yes, sir.
Actually this is horizontal force, and this is vertical because it is acting on the acting on the vertical plane. Okay. Okay, so we have the vertical forces because this vertical acting on the vertical plane. Okay, so let's draw this one. Okay, this is the same. Alright, so do we have any other forces? Okay, of course we have another force, which is,
The pressure force.
yes, this is force. The force always perpendicular to the plane surfaces. Okay, must be perpendicular. Alright, so for this case, let's define the resultant force. Where is the resultant force for this horizontal? It is at the middle, right? This is Fy. Alright, sorry, this is alright, Fy. Okay, and then we have the resultant force at the vertical plane. Where is the resultant force? It is here at the point P. This is Fx. Do we have any other forces? Anyone? Do you have any other forces? Is the wake considered as the force? The wake
Yes.
is, yes. So we have the wake here. Wake. And then we have what other forces? Okay, we have the summation of force. This might be like this. This is Fr, and we have to separate here Fh and Fv, vertical. Alright, so for this case, it is very simple for you. Why I say so? Because just use summation of force, okay, in x direction equal to 0. So what's the force involved in the x direction? Fh and Fx, right? So Fh, it is pointing to the right, and minus Fx equal to 0. So force in horizontal is equal to F of x. Okay, clear so far?
Yes, doctor.
Okay, how about summation of force in the y direction?
FV minus FY minus W.
Fv minus Fy minus W equal to 0. So Fv equal to Fy plus W. Alright, is it simple for you? Is it okay, right? Do you understand so far? Everyone?
Yes.
Okay.
Yes,
So
doctor.
the last part is that if you want to find the resultant force, just put this way. Fr is equal to square root Fh squared plus Fv squared. This is the magnitude of resultant force. If you want to find the angle, for example, this is angle theta, just use this cosine rule, tangent rule. Tangent theta equal to FV over FH. It's very simple. Okay, so far. Do you have any question? Okay, I think that's all for today. I want to intro for you the concepts of the force on the curved surface. For the next week, it is easy for you to go through for the example as well as for the concept. I think this is quite simple, right? Because this involves of summation of force in the x and y direction. Okay, I think that's all for today's session. Do you have any question?
Thank you, Doctor.
No question.
Okay. Okay, but then